This video is 11th from Semiconductor in Engineering. Today, we learn about other paths and BJT. Other paths include Group 3 and Group 5. Leapers, HEMT, and MESFET and JPET, and multi-gate transistors. First, the HEMT is a high electron mobility transistor designed to compensate for the shortcomings of velocity saturations. In an MFET, an N-type doped GaAs gallium arsenide is doped into a source and a drain, and an undoped aluminum gallium arsenide is doped into an ion implanted lesion. However, the disadvantage of this is that the structure is complex and expensive to process. The AS is toxic and the interface is not very good, and it is difficult to make a dielectric, so it is used when it is related to the military or the universe. Next, the JPET is called a junction FET. This is used when using a motor or LED and can be used in enhancement by adjusting the depletion. This is done by placing heavily doped F in the gate and substrate in the MFET and applying depletion to the P FET lesion by putting the ground and negative bias in the N lesion, and then applying a positive bias to the drain to adjust the overlap lesion. Next, the MESFET is a type of JPET that is used when there is no good oxide. This also uses the height of the barrier when the bias is applied, using the depletion lesion between the channel and the substrate. Silicon on insulator devices are prevent punch-through by inserting the insulator into the substrate to prevent depletion from overlapping. However, the thicker the box, the lower the thinner conductibility, the higher the temperature inside the device itself, the higher the power consumption. There are various kinds of multi-gate transistors, and they have gradually development from planar double-gate, 3-gate FinFET, ultra-thin body, SOI, gate all-around, NW FET, lateral or vertical. So, when this goes to FinFET, the thinner the current, the more current flows through the channel. The thicker body, the harder the control in the body becomes, and the better the punch through or roll off. Also, the resistance of the channel increases and the transistor becomes larger, eventually resulting in the series resistor phenomenon. BJTs are bipolar junction transistors. Bipolar transistors that use two carriers and eventually flow more current. BJTs are different from MOSFET in that they both source and drain, emitters and collectors, and emit and correct carriers. The gate is also the base. As a result, current follows and eventually amplifies and acts as an amp. Operation is based on NPN, where N has electron and P has hole, depending on how the bias is applied. It is decide whether electron flows or not. When the barrier is lowered, the incoming carrier exponentially increases. BJT mode is divided into cutoff, active, reverse active, and voltage saturation, depending on which bias is applied to. Emitter base, or corrector base. There is common base or and a common emitter, which applies a voltage of 0 to the base and emitter. In other words, it is working the ground. Then, if you hang it on the base, and the output resistance becomes large. However, since there is nothing to give, gain is kept at 1. However, in the case of common emitter, input signal and output sign are inverted due to the Miller effect, and the gain is 100.